Basic switch configuration. All right, in a network, our layer 3 devices, such as routers, are the tools that we use to connect subnets and LANs to each other, right? So if we view our subnets as cities, routers will represent our highway system connecting those cities to each other. So where do switches fit in? All right, well, they're the streets, the boulevards, and the roads within our subnets or LANs. Without switches, our cities would consist of Main Street, and that's about it. In this nugget, we're going to learn how to build our switch configuration to expand our subnets. How are we going to do this? Well, we're going to start off first by looking at some console requirements as far as configuration and connection. After that, we're going to look at management commands. And when I say management commands, we're talking about more of the global configuration of the switch and the management of it. And then we're going to get into detailed configuration as per the interface, slash ports, if you will. Remember that on layer 2 devices, we normally term them as ports, but they can also be termed as interfaces. Want to get you used to that. All right, let's dive in. To make our console connection, we're going to have to start out with some hardware, and I'm going to show you the hardware here. Here you see my drawing of what would represent a PC. It doesn't have to be a PC. It can be a dedicated piece of hardware to connect to the console, but this is most common. Then over here, you're going to have your switch. Now, all switches don't look alike, right? What I've showed you here is just a 1U thick switch, and I'm going to show you the console port. This is the tool that we're going to use to connect into this switch. This console port is going to be available on every Cisco switch that you find. Now, it may not look like this. Remember, other switches are chassis, right? They have blades in there, a number of blades. One of those blades will have the console port, okay? All right, moving along, here we go. What do we require over here on the PC end for our connectivity? Well, it all starts out with a couple of options on the back of our actual PC, and those are called COM ports, communication ports, normally numbered COM1, COM2, and so on down the line. As I said, you normally have 2, but you can have more. All right, this is going to be the basis for our interface within our PC, or this end of our communication, right? Over here, we've already said that our console port will be our communication port on the switch. What do we need in between? We need some type of cabling, right? Well, before we get into that cabling, what we have to cover is the type of connectors on each end. Let's start over here with the communication ports. These are going to be connectors that are known as DB/9 connectors. In short, just DB9 connectors. Let me show you what that's going to look like. Let's see down here, right here. All right, our DB9 connectors, they're provided by Cisco #1, so you don't have to worry about going out and finding this connector. It'll be in the box with the equipment. This is what it's going to look like. And it's going to be labeled terminal here. But more importantly, here's the 9-pin connector that's going to go into your computer. And as you can see, they're numbered 1 through 5, 6 through 9. The female end is going to be here on this connector. The COM port has the male end. On this other side, we have an RJ48, right? Which means that an RJ45 can plug into here. Those are those UTP ends that we're used to. All right, so now that we have the basis for connectivity on that end, right here we have our DB9. So let me draw that out if I can. All right, and then we have our RJ45 connector. Well, that clues us into the fact that we're going to have some type of unshielded twisted pair cable running from this COM port over here to this console port. Now, once we get to the console port, can it plug in just as it is? In other words, that RJ45? Well, in some cases, yeah. This connector is just going to have that little keyed option right there so that we can connect our RJ45 into that device. Now, other switches are going to have a different connection, and that's going to be the DB25. Now, as you can guess, over here with the DB9, we had 9 pins, right? So you get an idea as to how many pins we're going to have here, but let me show you the actual tool that we're going to use right here so you know what you're looking for in the box. Looks like this. The female connectivity on this end, again, 25 pins, 1 through 13. 14 through 25, and on the other end, we have that RJ48, what we're going to plug in our RJ45 cable into, all right? So this is what it looks like, and you can use it on your devices straight out of the box. Now, the other thing we have to cover is this cable right here. What are the requirements of the cabling or the wires and their connectivity? Here we go. All right, I'm going to draw my RJ45 end on this end, my RJ45 end on this end. As you know, we have 8 pieces of wire within this cable, right? This is what we're going to do. Wire number 1, 2, 3, 4, 5, 6, 7, 8, right? Starting with 1 at the top, 8 at the bottom. As these wires connect through this ribbon cable right here, on the other end, they're going to be flipped. In other words, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have 8 different. Right here, 8 is going to be on the top, 1 is going to be on the bottom. So you see that in here, they were rolled over. And in fact, this is called a rollover cable. You're going to need this rollover cable for the connectivity between COM1 or COM2, whichever COM you choose, and the console. All right, so that's our physical requirements as far as connectivity. But once we've done this, we're not ready to fly, right? We need one other thing. In other words, we've made the road here to continue our analogy of streets. Now we need a car to drive over it. That's where we get into the software. Now, when I'm talking about software, I know that the switch already has an operating system. I don't need additional software there. It's just waiting to be talked to on this console port. It's just sitting here listening. You got anything to tell me? It's over here that I need a special type of software, a terminal emulator, so that I can interface with this switch. Now, there's a couple of options. With a Microsoft environment, if that's what you have, there's something that comes free with that environment. That's HyperTerminal. Now, this is going to be available for your use. It doesn't have all the bells and whistles that you will find in other programs that can achieve the same type of connectivity. In fact, let me show you a HyperTerminal here. Let's go down here. You go up to Programs, within Accessories, and this is going to be true of any Windows operating system that you have, and then you jump into Communications. Here you see HyperTerminal. Normally, this is what you would pick if you had no other choices. I do, and what I like to use is Secure CRT over here. Now, this is something that you'd have to pay for, but in my opinion, it's well worth the money. So I'm going to connect via this software here. What you're going to find is an option here under Quick Connect. Now, this software isn't just used for console connections. You can see here, I have the choices of SSH1, SSH2, that's Secure Shell Connectivity. In other words, it's an encrypted form of like the R commands, remote connectivity, okay? Telnet here, which you're used to, R login, serial. This is what we're looking for. Serial connections are what we're running between our PC and our device. Now, I look here and I identify which COM port I'd like to use. Remember our discussion, most computers have 1 and 2. Others can have more than that. I'm going to opt for COM2. It's the cable that I have attached. Then I'm going to look at baud rate. This is the speed that I want to talk. Some people talk really fast. Some people talk slower than that. Same thing with devices. They want to talk fast or slow, and you have to have the speed match up. Now, there is a standard speed for Cisco devices, and that standard speed is 9,600, also known just as 9,600. So what you have as a baud rate by default will be this. It can be changed, and you can do that for security reasons, because everybody knows, as I just told you, that's involved with Cisco devices that this is the default speed. If you'd like to change this, it'd make it harder for people to try to gain connectivity to your devices. All right, moving on. Data bits. This is the number of data bits that will be received in succession before you get a stop bit. 8 and 1 are the default. None on parity. Once you have all these options set, really you're just going to change this one here and select COM2. Then you go ahead and connect. Upon connectivity, you're going to see the screen get a little bit larger there, and then we're going to gain connectivity into our switch. Now, the switch itself at this point, I just turned it on, so it's going through its boot process, as you can see here. The Cisco 2900XL going through its boot loader. As you can tell, it's a 2900 series switch, and it's going to initialize the flash. Remember, this is a form of memory. I want you to understand this in our basic configuration because you're going to see all this information. Don't think that you're having any problems with your switch. It's simply coming up. It's going through its boot process, learning the environment, and saying, okay, I'm getting myself ready to play in this environment. Once I'm ready, I'll let you know, and it's going to come up and say, hey, hit return right there. Press return to get started. So I press return, and our prompt is going to come up. Now, the prompt that you're going to get, remember our 2 levels of operation, right? The user mode and the privilege mode? This is going to be the user mode. To switch up into the privilege mode, you simply type enable as a command, hit enter, and then you're at the privilege mode. The way we knew the difference was the prompt. Here we have this prompt. Here we have the pound sign. Now, I just indicated that we could actually change that speed. I want to show you where to do that and how to do a couple of other things. The first thing I need to do, though, is size this window so you can see the commands back here. All right. Obviously, I'm going to be in configuration mode when I make these changes, and then I'm going to opt to get into a more specific type of configuration, and that's line console 0. Remember, we said that there's going to be a console port on every switch. Well, this is what it's identified by, line console 0. Once we do that, we're in the configuration of that specific line. So let's see that up here in our environment. I'm going to go into configuration via terminal. I'm going to type in line con 0. Remember, you can abbreviate those commands. It's still line console 0. All right, the first thing I'm going to do is type in speed, space, question mark. Got to love the question mark. So it can give me my parameters that I can enter here. And here it is, 0 to a lot of seconds, okay? So this is going to be any speed that we'd like to set within that increment. As we said, 9600 is the default, so 9600. Stick with that in most cases, like I said, unless you want an additional layer of security for console connectivity. Remember that this isn't something you can do remotely. When we're talking about console connectivity, you have to have physical access to the box. So if you have good physical security, you may not need this, and you won't want it because then it may confuse your administrators, your coworkers, things of that sort. All right, so we're going to leave the speed at 9600. Let that go. The other things you see down here are the exec timeout and the session timeout. What we're saying here is within the exec timeout, that's the privileged mode. We're saying how long can we be in the privileged mode before we're knocked out. All right, this is total time. Now the session timeout has to do with idle time. On some occasions when we're logged into our devices, we'll log in, we'll commit a few commands, and then we'll go into other programs down here that we're working, forgetting that we've logged in. This takes care of making sure that we don't take up that space or leave that connection open when we didn't want to. After a certain amount of time passes, you'll define that here, then it's going to go ahead and automatically log you out. That's what I meant by knock you out of here, sorry. It's going to log you out, all right? Well, let's see what we can set on those parameters up here within our box. All right, switch configuration line, we're already in there. Remember, we need to be there as identified by this prompt. And now we're going to type in exec timeout. Hit question mark. There you go. Here's our options. It's between 0, 35,791. Remember, this time it's in minutes. We're up here. We had that interval in speed as far as baud and things like that. This is a different measurement. All right. Normally, with exec timeout, you're going to set that pretty high because you want to be on the box for a good period of time, especially in the lab environment. So I'm going to go ahead and set that to 60 at this point. And then we're going to set our session timeout. Again, looking at our parameters, the same exact options that we had with our exec timeout. Now, you want this to be lower within your working environment. I'm in a lab, though, so I'm going to set this a bit higher and go ahead and leave it at 30 minutes here. All right, once we set those up, we've finished with just our initial configuration of some of our line parameters, and we've definitely covered the console, how we connect physical requirements, the software requirements here that we have within the device, and then these configuration options. Now, one note before we leave here, I want you to make sure that you understand that when we make these configuration changes, as we did here, to our switch environment in the 2900, which is what I'm working on here, with this specific operating system, I am going to have to save the information to NVRAM. Remember the concept of having RAM, random access memory, which is a temporary level of memory. When we make these configuration changes, that's where they're going to show up at. At some point that we feel confident with those changes, we need to run a command so that we can move them into NVRAM. In other words, we could lose power and that configuration still stays there. RAM, we're going to see that in our running config. Remember that, same thing as we saw in the router. And then NVRAM is going to be in our startup config. So when you want to copy information from RAM to NVRAM, it's simply copy, space run, space startup. And then you'll have it. Actually, if you want the full command, it's copy space running dash config space startup dash config. But this will do it right here. Copy, run, start, and you can have all the information saved. So you need to understand that so that you don't make this configuration and then lose it at a later time. All right, that's going to do it for the console. Now let's move into our next area, and we're going to talk about management configuration. We're talking about, as I said in the intro, more of the global configuration of our devices. We're going to start out with passwords. All right, as you see here, I'm in the configuration mode, not in the configuration line, so this is going to tell us that we're looking at some type of a global setting, right? Now, within the global setting, what I can set is the enable password. So I'm going to type in enable. And after that, I'm just going to hit question mark because I'm going to have two options. I'm going to have the password option or the secret option. You got to ask yourself, why do I have two options? Here's the explanation. First of all, we had this password option. It used to exist alone, just the enable password. What was found, though, is that the security surrounding that password lacked. In other words, it could be broken. Even though it could be encrypted, it could be broken, okay? So what we needed was the enable secret, a higher level of security within that password and the way it's saved on the configuration so that it can't be cracked as easily. And to date, can't be cracked. All right, so we're going to set either the enable password or the enable secret. Obviously, because of the better security, we're going to opt for the enable secret. If for some reason, though, you set both of these, the enable secret would take precedence, and this really wouldn't exist, right? All right, then from there, what we need to do is we need to configure a password on the line. We say, well, why do I need to do that? All right, remember back to our router. We had different levels, right? We had a user level of configuration that you enter into, and it was identified by this prompt. Then you type enable, and you had a privilege level of configuration, and that privilege level was identified by the pound sign, right? Well, here we go. This is how we get to those different levels. This line password is what's going to control your access into this user level. If there's no password, you get there automatically. Remember when I logged into my device a minute ago, I just automatically got to that prompt without a password. That's because this wasn't set. All right, what we do here to get into this interface is is line space console space 0, like we did in our example last time. But once you're in there, once you're in the config line, you simply type out password space 0. This lets it know that it's an unencrypted password coming, and then the password that you want. In the case of our lab, we're going to type in Cisco. Let me show you both of these on the device. All right, let's get the device up right here. And here we go. I'm still in the configuration mode, and as you can see, I'm in the line mode. So I'm going to go ahead and configure the password. Let me bring this down a little bit. For the line first, and even a little bit more right here. And that's going to be this command, the password 0 command. All right. Actually, I need to raise it so you can see. All right. Password. I'm going to hit a question mark here because I want you to see what I was talking about with that 0. 0 specifies an unencrypted password. 7 if I wanted to have a hidden password. And then line if I just wanted the unencrypted clear text password. I have the habit of entering 0, space, and then Cisco. This is going to be our password. You hit enter, you're good to go. Now, for our other password, that enable password, we've got to be in this higher level configuration, right? So if we type in exit here, we're not going to exit the whole configuration mode, the config T. We're just going to exit the line. You'll see that here. Watch. Hit enter, and there you go. We just stepped right back up to where we started, the configuration on a global scale. Now let's go ahead and enter enable, secret, 0, and then we're going to type in the password that we would like. We're going to say Cisco there as well, and then hit enter. Now we've set up our passwords for the different levels that we can use, the user level and the privilege level. Next thing I want to talk about is banners. What are banners used for? Banners are going to allow us to pass information at key login points to whoever's trying to log in. Now we're going to show a couple of banners. The first one I'm going to show is banner. Now as you can tell, this is a command because we're at the configuration prompt. Banner space login. Now as you might imagine, this is going to show up as we're trying to log in. But where as far as the login process? This is going to be before we're asked for a password. So before we even ask for a password, we're going to get this verbiage up here. The intent of this for the most common use is that you can say, okay, this is a restricted device, restricted to, and why, and in any kind of law that may set precedence why somebody who is not allowed access cannot get in here, okay? So you can have that information there. And then another type of banner we're going to have, again, it's going to have to be identified as banner, space, but this time it's exec, is going to come right after we supply that password, right after we supply the password. And this can be information that you want to relay to somebody who does have access, who should be in here, but hey, you know what, you need to watch out for these important things, or make sure when you configure you do these important steps, things of that sort. Well, let's check that out within our device. We're going to go back here to COM2. As you note, I logged out of the device. This is why. I'm going to hit enter. I want you to see the password information that we put up here in effect. All right, password is going to ask me for. I'm going to type in Cisco, as I identified before. I'm going to type in enable to go up to the next level of privilege. And again, I have to supply a password. Pretty cool. We know that our configuration, as far as passwords, took. Now we're going to make the changes we need as far as the banners. Now, it's going to be a global command, as we identified before. Banner, space, login, space. Now, it's going to, here, let me hit question mark so I can show you. It's going to say, give me a delimiting character. In other words, here's the C, then the banner text, and then the C again, where C is a delimiting character. You're not locked down to C, and this is the reason. C is a pretty common character, right? So you don't want to mistakenly have it chop your banner text in half. I usually use Z. So log in, and then at this point, let me get that cursor out of the way, Z, space, your text that you would like to see there. So I'm just going to type in login banner so that you can see where it's at, and then space, another Z. Hit enter. It takes that information. Now let's go to our other banner, which is going to be banner exec. Again, the same thing. I'm going to type in Z. I'm going to say exec, banner, space Z. Hit enter. If I'd learned to spell, we'd have that done correctly. So let me do this. Oh, the recall, the up arrow is going to give you the last command that you entered. So that's a really good service, if you will, so that you can bring these commands back and then make little changes, as I just did there. And then we hit that in. Now we've got it. Banner exec Z, exec banner Z. Let me control Z, which is how I get out of my configuration. And now what I'm going to do is I'm going to exit out of this system completely. Now let's come in. Now you see the difference. Before we were asked for the password, we got that, but the difference is here. Here's my login banner I told you about, where we can say, this is a restricted system. Type in the password. As soon as I hit enter right now, There you go. After that password prompt, here's the exec banner, where you can give information to people that are allowed access, but you want them to know certain things about this system. That's where you would provide it. All right, so at this point, we've covered passwords under management, and we've covered banner. Let's move into some other concepts of management, and that's going to be the management IP address, and then after that, we're going to talk about ping and traceroute. All right, management IP address. First of all, let's make sure we get this into context here. We're talking about a layer 2 device, right? Now, as a layer 2 device, it has all these interfaces / ports, depending on how you're identifying them. And you know that they don't have IP addresses. These are MAC addresses because they're layer 2 addressable, right? So you ask yourself, why do I need an IP address then? And the reason for that is simply, as it says here, management. If you want to telnet into the box from another device, let's say I have N1 here, then I'm going to need that IP address. If you're doing some type of reporting to a server, then that communication between that server and that device has to have an IP address to identify the communication, right? Here's where we're going to set that up. All right, and so you see the steps here. As you can tell, we're going to start out in the config mode, and then we're going to move into config interfaces after that. All right, let's jump in up here at the top. I'm going to have the config, and we're in global mode here, identified, and what I'm going to have to do is identify what interface I would like to get in. Now, remember our example is on a 2900, right? Within this 2900, it's interface VLAN 1. Okay, once we've identified that, it switches into this interface configuration. Now, once we have that, we simply type in a series of commands. The first is going to be shutdown with a no in front. Tried to trick you there. No shutdown, okay? And then the next thing we have to do once we've turned this on is assign an actual IP address. So it's IP space address, and then the address that you would like to see that device have. In this case, let's supply 192.168.1.200. And then you've got to supply the mask, 255.255.255.0. That's so it'll know what the local subnet is, and if it has to get out of the local subnet, it can use a default gateway. And that's what we're going to assign next. Default dash gateway. Remember these conversations from our other nuggets within this series. Default gateway, and then you're going to assign the number 192.168.1.1, and it knows where the door is to get out of this local room. After that, if you want, and this is optional, you can type in a description saying, hey, this is what that interface is used for, just some text here, anything you want known about the interface. Once you've done that, you're up and ready and can participate with that IP address on this device. In other words, it has one layer 3 entity, but it's only used for management. Now, as far as management uses, we just talked about remote connectivity, but I also want to talk about troubleshooting. Within troubleshooting, we use the ping command and the traceroute command. Let me draw something out for you. Let's say I have N1 here that's connected to switch number 1, and that's connected to router number 1, and then on the other end of that communication channel is N2, another device. Now, they're going to enjoy that connectivity. Sometimes I want to do some troubleshooting. If I use the ping command from N1, which is going to be 192.168.1.254, to ping over here to .200 as we identified here, right? 192.168.1.200, I'm going to successfully get that ping back because it can ping that management interface. But if I want a trace route between N1 and N2 as a destination, it's not going to pick up that IP address. This is why. As we're going through here, it enters a port, and it looks at the layer 2 information as far as forwarding that information right out of that switch to the next device. The router here actually goes up to layer 3 and looks at the IP address. The normal operation of a switch doesn't. This IP is just for management, right? So you've got to understand, in a ping, you'll be able to ping that address, but under traceroute, you won't see it there. It'll go 192.168.1.254. The next thing it's going to report is this IP address right here, which is going to be 192.168.1.1, and then the IP address over here on this interface, completely skipping this. So traceroute won't be a good tool when you're trying to verify if a switch has connectivity or not. Use the ping. Well, that's going to do it for my discussion on the management configuration within the switch right now, because it's the basic configuration. There are many more options available. In fact, you can go into protocols if you wanted to, SNMP, CDP, and configure them and how they operate within this switched environment. Keep in mind, I'm just giving you the basics, getting you up and started and running. All right, let's move on to the interface configuration commands, which is going to be the last part of this nugget, interface configuration. Now, when I'm talking about interface configuration, let's see here. I got a 29, 24. This is what I have in my lab. It's a 2900 series switch with 24 ports, meaning these little holes in the front, right? It's 1U thick, and they're going to be numbered 1, 2, 3, 4, 5, 6, on down the line, all the way to 24. Now, I need to configure some parameters for these plugins. Remember, to give you an idea of how we're going to use this, N1 is going to have connectivity via UTP into this port. This is what bridges the two together so that it can talk over here to N2, right? It goes through the switch to do that. All right, when I'm talking about these interface parameters, there's a couple of things I can set. The first one is going to be speed. When I'm talking about speed, normally the option is going to be 10 meg, and then some others. Unless you have like a 1900 switch, that's all it may support on that specific port. But if it supports more, you may have 100 meg, and if you go into the higher level switches, you may even have gigabit support. Once you know your speed options, it's important to set them here within this port here. Let's say port number 1 I set to 100 meg, and also make sure you have the capability in the device that is connected to. If I have a network interface card here on N1 that only supports 10 meg, and I set this at 100, guess what? I'm not going to speak. There's going to be some errors there, right? So I need to make sure that they match identically here. All right, beyond speed, we can also set duplex as a parameter. Now, when we're talking about duplex, we're talking about the direction of speaking. Let me explain that. Probably better described as the direction of conversation here. This is what we're saying. Under normal operation, N2, if it's transmitting data over to this port, number 2 here, it can do that, but it cannot receive. It can transmit only, and the port can receive, as it's doing here, but it can't transmit, right? This is normal operation, and that's called half duplex because it's taking care of half the conversation at one time. Now, if you enable the ability to transmit and receive at the same time for both the port and the device, now you're in what's known as full duplex mode. I opt for full duplex mode whenever it can be supported because it gives you more use of your bandwidth. Now let's look at the configuration. I'm in global configuration here. First thing I'm going to have to do is identify an interface that I can go ahead and configure. And you're going to do that by saying interface, fast, Ethernet. Now remember, you can shorten this up to just fast if you'd like, and I would recommend that. But fast Ethernet, identify the module first. In my example here of the 2924, there's only one module, and that's module 0. It's not like a chassis like this where you'd have 0, 1, 2, 3, and on down the line. Module 0, and I'm going to stick with port or interface number 1. Once you've done that, the prompt change, and it doesn't change like this because I made a mistake here. It's config-IF. Let me take care of that on both of these. Because we're configuring within an interface, not a line like we had earlier. It's actually good that I had it there like that so I can draw particular attention to that. This is config interface. All right, once we've set that up, as we set up here, our first option we're going to go for is speed. If I type in speed space question mark, it's going to give me the options available. Under this 2900, they are 10, they're 100, and we're going to throw one in. It's auto. Now there's a note with auto. If you use auto negotiation in this 2900, then what it's going to do is it's going to auto negotiate both speed and duplex. So it's very important to know. Our next option is going to be duplex. As we talked about, we have both the half option and the full duplex, and as you might have guessed, we also have an auto option. Keep in mind that when you use auto, it's going to negotiate between the port and the device, and it's always going to try to go with the fastest first. So it's going to try full first. If there's no negotiation successful, trying to go full duplex, it says, okay, well, let's settle for half duplex then. Now take particular note here that we didn't do any configuration as far as addressing, and the reason for that is, as we talked before, this operation of communication between these ports is going to be done at layer 2. Now layer 2 addressing, guess what? Already provided here. It's that MAC address, right? The media access control. We don't have to program it in. It's hard-coded within the switch configuration. That's why you don't see any addressing parameters. All right, that's it for this nugget. In this nugget, we started out by talking about console connectivity. While we covered that, we started out with hardware requirements. We had a few of them. First of all was the COM port on our device, and we identified what it was. And then we talked about the console port on the actual switches with the Cisco environments. We talked about connectors, the DB9, the RJ45, the DB25, and the rollover cable that's required for connectivity between those connectors and those devices. From there, we went into management configuration. Here we talked about passwords, banners, and management IP. We even threw in a troubleshooting tip as far as ping and trace route and the effects they have with this management IP. And then we ended up talking about interface configuration. We just covered that. I hope this has been informative for you, and I'd like to thank you for viewing.